calculate the mean, mode, and range from a frequency distribution. First thing to think about here is that a frequency distribution is just a frequency table where we'll have our list of values and then the number of times in which they occur, and it's a more convenient way to record the data. Especially when there's a large amount of it. It's just so much quicker than having to write it down individually. All the median, mode, and the range can be calculated directly from the table. To work out the mean, we use this formula, which is sigma fx divided by sigma f, where the sigma, so it's a Greek symbol, it represents the sum of, f is the frequency and x is the data value. Fx is the product of f and x, so that's frequency multiplied by the data value and then added up, divided by the total frequency. The mode, if we're working that out, it's the value with the highest frequency, so it's not the actual frequency value, it's the data value that contains the highest frequency. And the range is the difference between the largest and the smallest. So the first example is a computer repair service. Received a number of calls per day over a period of a length of time. Using a frequency table, find the mean number of calls per day and what's the modal number. So what we first have to do is put this into a tally chart. So for our frequency table, we're going to have the number of calls, and then we're going to have our tally, and then we'll work out the frequency from that. So we're going to start off with 2, 3, 4, 5, 6, 7, 8, and 9. And the first one is a 6, and then a 5, a 6, and then a 9, 7, 4, 2, 4, 7, 8, 3, 4, 9, 8, 2, 3, 5, 9, 7, 8, 9, 7, 5, 6, 7, 7, 4, 6, 2, 4. The frequencies then are 3, 2, 5, 3, 4, 6, 3, and 4. Now our frequency is obviously our f value, and the number of calls, that's going to be our x. So if we're working out the mean from a frequency table, we need to work out our fx values, which is f multiplied by x. So if we multiply 2 and 3 together, that'll get us 6. If we multiply 3 and 2, that's another 6. 4 times 5 is 20. 5 times 3 is 15. 6 4s are 24. 7 6s are 42. 8 3s are 24. And 9 4s are 36. So what we now need to do is work out the totals of the frequency and the totals of the fx column. To do that, we just add them up. So the frequencies add up to 30 and the fx add up to 173. So the mean is sigma fx divided by sigma f, which is 173 divided by 30, which works out to be 5.77. The mode, again we're asked for the mode, the modal values to do the mode, hits the one with the highest frequency, and we can see that the highest frequency is 6, which corresponds to 7. So the modal number of calls is 7. Now just to quickly explain the rationale with this fx, if we were to put all the values in order, what it would have been was 2, 2, 2, 3, 3, 4, 4, 4, 4, 4, 5, 5, 5, 6, 6, 6, 6, 7, 7, 7, 7, 7, 7, 8, 8, 8, 9, 9, 9, 9. So rather than adding all those up, if we group them, the 2, 2, and 2, they would add together to give 6. There were 2 3s, and they'll add together to give another 6. The 5 fours add together to give 20. So really what we have is that the frequency tells us how many of the number of calls that we're going to add together. So rather than doing it in a big long list and having it as a single fraction, by adding them together, or by multiplying them together and then adding the fx's, that tells us what their total is. So in the next example, we're finding the mean, the mode, and the range of the following data. So we've got the number of clips and the frequency. So frequency is our F column and the number of clips would be the X. The total, so if we add up all the frequencies together, we get a total of 20. And the mean is our sigma Fx divided by sigma F. So we need to work out an Fx column. So Fx is found by multiplying the frequencies and the X. So all we need to do is multiply across all of the number of clips and the frequency. So 95 by 1, 96 by 2, 97 by 4, all the way to 102 times 1. Whenever we do that, we get the following values. So 95 times 1 is obviously 95. 96 times 2 was 192. And then we get 388. 392, 693, 100, 0, and 102. And when we add those all up, we get 1962. So this is the sigma fx, and this is our sigma f. So put those into the formula, we get 1962 divided by 20, which works out to be 98.1 clips. To work out the mode is the highest frequency. The highest frequency is 7, and that relates to 99 clips. The range is the largest value minus the smallest. The largest is 102, the smallest is 95. Take those away and we get 7 clips. Very often then, if we have large quantities of data, rather than having individual values like we've had in our past two examples, quite often it's a lot easier to group them. So in the example below, it talks about height, and rather than looking at how many people are 130 centimetres, how many are 131, 132, all the way up to 155, and we could think about the same in the classroom. There's probably people ranging from 100, maybe 45, all the way up to 185, and rather than doing every single height individually, it makes much more sense to group them. Now, group data means that we can't have the exact values for the mean, the median, or the mode. We'd have to use an alternative method to figure out the exact values. So what we can do is just find an estimate. Now, whenever we're using our formula for mean, it's sigma fx. So the frequency is still the same, but the x value isn't. So we have to try and figure out what the best representative for each group would be. And really the midpoint, the middle of those, is going to be the best value that we can use. So it's going to be our estimator. So same idea. What we do is we need to work out our midpoints. So I'm going to add in an extra couple of columns to the table. The first one is midpoint. And we're looking for the middle of the 130 to 135 group, which is 132.5. Middle of the next is 137.5, then 142.5, 147.5, and 152.5. So those are our midpoints. We then need to work out what our fx values are. So the frequency is our f, are the f values. The midpoint is the x, it's the data representative, and then we need to do our fx values. So frequency multiplied by midpoint, so the first one is going to be 1,325. And then 15 times 137.5 is 2,062.5. Then we get 2,422.5, 1,622.5, and 305. So for mean, it's sigma fx divided by sigma f. So we need to work out the sum of our frequency and the sum of the fx. So if we add the frequency columns, so add the 10, the 15, the 17, the 11 and the 2, we get 55 for that. And if we add the fx values, we get a total of 7,737.5. So sigma fx over sigma f, we're going to do the 7,737.5 divided by 55, and that works out to be 140.7 to 1 decimal place. The modal group then was the next that we had to work out, and the modal group is the one with the highest frequency. So 17 has the highest frequency, but 17 isn't the mode. The modal group then is everything from 140 to 145.